No, that was from last year. Okay, so our absolute value graph starts at 0, 0. And this would be my original shape, right? It's in the shape of a V, always in the shape of a V. Then I have to shift this graph, and the shift depends on this number and this number. Does anybody remember what's special about the inside number? It's the opposite, and that's left or right. So this is the opposite and left or right. So if this is 2, what is it telling me to shift? To the right 2. And then what does this plus 4 tell me to do? Up 4. So here's my new vertex. I've moved the vertex. Then this 1/3 tells us something about it. And I told you on the video to think of it like slope. So if I'm rising 1 and running 3, is this going to be wider, narrower, or the same as my original graph? Wider, because you're going up 1 and out 3. So you don't have to make it exact. I just want you to show that it's wider than the original. And that is everything from yesterday. Okay? The shape of the graph is always a V. Opposite on the inside, same on the outside. And this tells you, think of it like slope, if it's going to be a wider V, a narrower V, or exactly the same.
So if the bottom number is bigger than the top number, it's always going to be wider?
Yeah, because you're going out more than you're going up.
Do we have to draw the original graph?
Well, if you don't, then you have to be specific with your slope. Okay? So, go ahead and grab your notes from yesterday. We're going to now go backwards, and I'm going to give you an equation, and I'm going to give you the graph, and you're going to come up with the equation. So this is just an add-on to, what was this, 2.7? Did I give you any notes on what makes the V upside down? The A term. So if the A is negative, good. Okay, let's stop talking. Okay, draw this graph. This will be your first example. Okay, so I'm going to draw a graph. Let's see. There's your vertex. And then okay, so here is our graph. We're going to write our equation. So we know it's going to be y equals something, absolute value, something. And we know there's an x in here. Okay, first thing I would pick out is what is the vertex. So the vertex here is at -1, +4. So to shift to the left 1, what do you need on the inside? +1, because you're going the opposite. And then to shift up 4, what do you need out here? +4. Because you go left 1, up 4. Okay, hang on. Got people that aren't with me yet. So this is the left. This is the up. This is always left or right on the inside. Always up and down on the outside. Then to come up with a slope, I'm just going to see, I'm going down. It's an upside down V, so I know it's going to be negative. And it looks like I'm going down 1 and then over 2. Down 1 and then over 2. So that means I would down 1 and over 2.
How did you get
Because the vertex went up 4. First thing you want to pick out is what is the vertex, because that tells you your shift. This is left 1, that's up 4.
Got it.
Okay?
You got it.
Okay, let's do another one, but this time I'm not going to draw a picture for you. I'm just going to tell you the information. So for this one, I'm going to tell you that you're going to shift the vertex Where does the vertex start always?
0, 0.
0, 0. So we're shifting the vertex. We're going to go right 4 and up 3. Our slope is staying the same. So the width of the graph is exactly the same. So we're going to shift this vertex right 4 and up 3. And we're going to write an equation for that. Okay, so try on your paper if you can. So inside here tells us left or right. Right? Correct? I mean. Okay, so if I want to go right 4, what do I need to have in here? Well, minus 4. And then out here tells us up or down. So if I want to go up 3, what do I need on the outside?
Plus 3.
Plus 3. And I told you the slope was the same, so that's your equation.
So if we're shifting to the right, we're going negative.
The inside is opposite. Inside is opposite. This is the same. This is left or right. This is up or down. Okay? Inside is always left or right, and this is true for, and I think I said it on the video, but this is true for a lot of functions we're going to see. If you can understand this shifting, opposite on the inside, and this is left or right, same on the outside, and this is up or down, you're going to be able to graph the quadratic graphs we do, the radical graphs we do, because all the shifting is the same. Like, it'll look different because it won't have absolute value signs, but you'll have something on the inside, something on the outside. That inside will go left and right, and it'll be opposite. Outside will go up and down, and it'll be the same. So once you grasp this, it's going to go with every function we do this year. Okay? So today is mainly a work day. I think I did both my examples I wanted to do. Today's mainly a work day. I knew yesterday would be a little rough because you were seeing it for the first time. But you can, I want you to work and use my book for answers so you can make sure you're doing it right. And your assignment, you're going to add this on to what I assigned yesterday. So some of you got it done yesterday. That's good.
What was yesterday?
I'll tell you, or can somebody tell him?
Page 111, 1 through 4, 8
Okay, so 1 through 4, 8 through 16.
Yeah, it was yesterday.
Okay, so all of this is going to be due. Okay? Add on to yesterday's and do today's. Basically, it's the same thing over and over and over again. There's only really one concept in this section, and that's being able to shift the graphs. Okay? Ask questions if you have them. Today's the day to get all caught